All right, so we're going to talk about accuracy and precision, okay? Accuracy and precision. And I know that you guys have seen the whole explanation about how close you come to the center of a target. Yeah. And so when they use that illustration, accuracy, at least in terms of target shooting with arrows, being accurate means how many of the arrows come close to that center point, right? Okay. And then precision is how closely the shots or the arrows are grouped together, even though they may not be coming to the direct point, correct? And so that's the difference between accuracy and precision. And the sciences, you want to be both. But what in the world does that mean in a science lab? Okay, in our chemistry lab? Well, what that's referring to is measurements. Okay, so they're using a target to kind of infer, or they're implying, and you're supposed to infer, that we're talking about measurements. So accuracy when it comes to measurements. Okay? Accuracy is how close, let's say repeated measurements come to the true or accepted value. And by extension, it could also be calculations. It's all calculating density. I have to do mass and volume. And so then the calculation would be accurate if the density I calculate come to the close to the real measurement. But that's based on measurements too. Yes? Got that? Okay. And then in terms of measurements then, precision is how close repeated measurements come to themselves or each other. So precise measurements, repeated measurements come close to each other. Accurate measurements come close to the real value. What? Yeah, sure. Well, that's measurements. But accuracy and precision also refers to the instruments we use to make measurements. Okay? Instruments that make measurements. Let me raise this up just a bit, maybe. Kind of see the whole thing together. So, when we're talking about instruments that make measurements, were you able to log on? Mine's working. You're on? While you take notes, Patrick, would you shut off that computer behind you and restart it? And let's see if we can't get that one up on the internet and check it out for me. When it's done, if you'll let Dalton know, okay? Thanks. All right, so with instruments that make measurements, that could be a ruler. Something as simple as a ruler. Or it could be our digital balance. Or it could be an analog graduated cylinder. Okay? Any of those things make measurements, right? Yes? Okay. So instruments that make measurements are accurate when they are set up in a way that gives you the real measurement, which means close to the true or accepted value. Yes? Okay? So this is pretty close to the same. How well the instrument instrument.
Is that a separate definition from the one?
Yes. Is set up and used. Set up and used to give a true measurement. Okay, the real measurement, the one you should be getting.
What is the word after B?
Instrument. All right. Precision then kind of sounds a little bit different. I think these two definitions of accuracy for both measurements and instruments kind of sound the same. All right. But precision means sounds a little different. To me, they seem to be the same, but they sound a little different to the ear of a lot of students. Precision with instrumentation refers to how small the measurement graduations are. Okay? So, for example, a graduated cylinder whose smallest markings are to 1 milliliter is less precise than one whose smallest marking goes to 1/10 of a milliliter. Does that make sense to you? Or a ruler. You might have a ruler that only goes to centimeters. That's less precise than one that measures in millimeters. Okay, which in turn is less precise than a caliper that measures to 1/10 of a milliliter, for example. And they do make calipers that go to hundredths of milliliters. Okay, anybody do machine tool stuff at RDA? So they have calipers that go to hundredths, right? A milliliter. Do they use milliliters there, or are they still work in inches over there? Inches. So they're still in the dark ages of it. No, I'm kidding. I'm joking. Okay. But most of the rest of the world, is millimeters, right? So there's some famous stories of, I think what it was like one of the probes they sent to Mars that was like, we're talking about millions and billions of dollars here, okay? Somebody assumed the measurement was in the metric system, but it was actually sent to them in the English system, which means inches, among other things. And so that little tiny difference, it seemed like a little tiny difference to us, ended up means that probe, millions and billions of dollars, is lost in space. But nobody knows what it is. One little error. So this was important stuff. Okay? All right. So you understand the difference between accuracy and precision here as it applies to measurements and instrumentation. So these definitions you should know from physical science. Okay? You should remember it anyway. This may be a little bit new to you. Okay? Instruments, accuracy is how close the instrument's set up and used to give you the true measurement, which kind of sounds close to this one. But precision refers to how small the measurement graduations are on the device. Okay? So if I have a digital balance that only measures to the 1/10 of a gram, that's not as precise as one that, like we have, that goes to the 100th of a gram. And in turn, that's not as precise as one that measures to the 100th of a gram. And we have a couple of those somewhere around here at this school. Okay? And you might use those in college. Those are really, really precise. They are so precise that they're closed up inside a housing so the air doesn't change it. Just currents in the air. And if you're using them, you have to set it and back away from it, because just standing close to it will change it. Okay? How? Well, that's really something for which you should take physics. Okay? You may have heard for every action there's an equal and opposite action. That's more kind of a mistranslation of Newton's principle. What it probably more closely means is for every force there's an equal and opposite force. So the force that gravity causes you to make on the floor, that is to say, it doesn't become a force until it acts on something. Gravity is an acceleration, and when it acts on you, you have mass, so it acts on you to make a force. That force is pulling you down against the floor. The only reason you don't sink through the floor is the force pushing back against you. So you are flexing the floor. You are making, every time you take a step, you make that floor move. Now you don't feel it, doesn't seem like it, but you're making that floor move. So when you step close to a really precise balance, that instrument will pick it up. And you can actually see the balance move. You can see the floor flex. Okay? Pretty cool, huh? All right. Any other questions?